Hi, this is Dr. Bob Morecook, and today we're going to be talking about the value, what they mean of correlation coefficients. Let me remind you also that if the arithmetic is done correctly, when you compute a correlation coefficient, the value will always be between -1 and +1. 0 being no correlation, +1 and -1 both being perfect. Take a look at these two columns of numbers. They're identical, so no surprise if you computed a correlation between the two of them, you would get a value of 1.0. The same thing is true for this column of numbers. I've crossed out column Y and replaced it with Z, but look how they go, 2, 4, 6, 8 under Z. It's perfectly proportional, and so once again you get a value of plus 1.0. You have a perfect pattern. Yes, if the change is proportional, you're going to get a value of 1.0. If it breaks, you'll get a smaller number. Now in columns X and Y, we have the same numbers as before, but they just run opposite of each other. It's still a perfect pattern. If you compute the correlation value, you will get a value of minus 1.0. In this slide, I've simply doubled the numbers in column Z. So once again, we still have a perfectly proportional pattern. Put these numbers into the formula, you will get a value of minus 1.0. The numbers run opposite of each other. If the numbers change in a regular manner with each other, you will get a large correlation. But now, let's take a look at this terrible jumble of numbers in columns X and Y. I wonder if there's some pattern there, some correlation. It's hard to look at and just say, sure there is. Why not do the arithmetic? In fact, let's give these numbers some meaning. Column X has the height of some people in inches and their weight in pounds. I wonder if there's a pattern, such that tall people usually weigh more than shorter people. Not always, but usually. Let's see. Indeed, in this particular classroom, there is a correlation, a strong one, between height and weight. Yes, there's the occasional short person who weighs a good bit, and the occasional tall person who weighs not so much. But there is a pattern. Let's start talking about the meaning of correlations right now. What you see in front of you is a grandfather clock, the time with a large pendulum. Now, if this is a healthy clock, the pendulum can swing to the left to minus 1.0 and to the right to plus 1.0. I think you would agree that in this case, minus 1.0 does not mean that the pendulum swings not as far as when it swings to plus 1.0. Let's just take that curved line and flatten it out. And 0 in the middle is no correlation. You could swing to the left to minus 1.0, perfect negative, or to the right to perfect positive. Remember, you cannot go less than minus 1 or greater than plus 1 if the arithmetic was done correctly. Okay, let's put the clock back in. That way we can sort of follow through on how we're looking at this. Here's an easy problem you might run into sometime. You're trying to figure out which of two correlations is bigger, 0.80 or 0.40. On the paper, you could make a mark where 0.40 and 0.80 are and figure this one out. Or you could do it in your mind by visualizing this. This is an easy one. Let's try a harder one. Which is larger, minus 0.80 or minus 0.40? Which one is farther from the 0 point? Which one is closer to perfection? At which one place has the pendulum of the clock swung farther? Minus 0.80 is farther from 0. Minus 0.80 is larger than minus 0.40 in correlations. Here's another problem. Which one is bigger, 0.60 or minus 0.30? Make the marks on the number line, and you can see that 0.60 is farther from 0 than is minus 0.30. That's an easy one. Let's try this one now. Which is bigger, greater, larger, minus 0.60 or 0.30? When you spot them on the number line, you can see that minus 0.60 is farther from 0 than is 0.3. Minus 0.60 is larger. Let's try another now. Which one is bigger, 0.45 or minus 0.45? By spotting them on the number line, I hope you would recognize that they are equidistant from 0, and thus they are the same size. Here is another one that at first glance may seem harder. Which one is smaller, 0.10 or minus 0.90? Mark them on the number line in your mind. You should be able to see that the pendulum has swung much farther to minus 0.90 than it would to 0.10. So the smaller is 0.10. That's the smaller swing, and it's the smaller correlation. Consider a situation where you're asked which is greater, minus 0.45 or 0.50. From algebra, perhaps you remember that the vertical lines on the sides of both numbers mean that you take the positive value of both numbers and consider them, not the negative. That's right. The number on the left we convert to positive form, and the number on the right we leave alone. And now you're asked which of those two is the larger, or perhaps the smaller. And now it's easy to recognize that 0.50 is the bigger of the two. Let's try another one now using the same technique. Which of these two is bigger? You're going to take the absolute value of both of them. The vertical lines mean that you're going to take the absolute value of the two and then compare what's left. Do you see what the problem has turned into? It's really very simple right now. And so, of course, minus 0.65 is the larger and 0.35 is the smaller, because you're really considering their absolute values. And here's an easy one for you. Which is larger? Which is smaller? Minus 0.37 or 0.37? This means, of course, that we're going to consider their absolute values regarding which is the larger or the smaller. Do you see what the problem has turned into now? Indeed, correlations of minus 0.37 and 0.37 are the same size. Please remember that the only method that allows you to make a cause and effect statement is the experiment. A correlation gives you a number answer that tells you how strong a relationship is. This has been Dr. Bob Morecook for Houston Community College. I hope that this short video will help you in understanding how to compare the size of one correlation to another, knowing which is the larger, which is the smaller. And remember, cannot be outside of +1 or -1. Must be within those bounds. Y'all take care and have yourself a great psychology day. And here's a little something for your amusement.